Hi everyone, I have here a sample problem of the assigned practice problems we have on Hess's law. So here it says calculate the delta H for 2NOCl to form N2 plus O2 plus Cl2. From the given reactions, we have 1 half N2 plus O2 to form NO with a delta H of 90.3 kilojoules. And then the second equation, we have NO plus 1 half Cl2 to form NOCl with a delta H negative 38.6 kilojoules. Now I decided to put this on a video because someone was asking, how do you know when to multiply and when to divide in using Hess's law? So here, this is a perfect example where one thing you have to remember when dealing with Hess's law problem is that there are two things you have to remember. The first equation here is the desired equation. That's what we're looking for. And you will always be given sets of reactions. It could be 2, 3, 4 reactions to manipulate. So this two given equations here are the ones you can manipulate for you to be able to come up with the desired equation here. So let's start solving the problem. Look at equation number 1. Equation number 1, we have in the reactant side, we have 1 half N2 plus 1 half O2. And in the reactant side, whereas in our desired equation, the N2 and O2 are actually found on the product side. Another thing we notice is that N2 here is only 1 and O2 here is also 1, whereas our N2 and O2 are both 1 half. So, what should we do now? For us to be able to get N2 and O2 on the product side, we will reverse the equation. We will flip it. Also, we have to think of how can I make 1 half into just 1? So, the only way is to multiply equation 1 by 2. Right? Because 1 half times 2 would give you 1 and 2. So that's what we do for number 1. Now let's take a look at number 2. If you take a look at NOCl here, it is actually in the product side, And on our desired equation, we have NOCl is in the reactant side. Another thing we also see is that it is 2 NOCl here, whereas over here is only 1. So that's a hint that aside from flipping the equation, we also have to multiply such that the NOCl will become a 2. So we'll multiply it by 2. Let's see what will happen. So the first equation, we learned that we have to flip and multiply it by 2. So we have here we flip it, right? So NO now becomes on the reactant side, and then the N2 and O2 becomes will be on the product side. So also we multiply it, so it becomes 2NO to form 1 half times 2 would be 1N2, 1 half O2 times 2 would be O2. And don't forget, when you multiply the entire equation, you also have to multiply the delta H. So we flip the equation, so originally it was positive, now it becomes negative after we flip it, and then multiply it by 2. So our delta H for equation 1 now is negative 180.6. Now, let's look at equation number 2. We said that we have to flip it because we want NOCl to be on the reactant side, and we also have to multiply it by 2 because the NOCl here is only 1, and then here we have a 2. So let's do that. We flip and multiply it by 2. We have 2 NOCl now to form 2NO plus, remember this one is 1 half. If we multiply this one by 2, that would give us a 1 now. So our Cl2 is a 1, which makes sense because we want only 1 in our Cl in the desired equation. So remember, we flip, so our delta H will change. So here we have negative. Now it becomes positive because we flip it, and then multiply it by 2 to give you a 77.2 kilojoules. So our total delta H is just simply add the two delta H's here. We would get a negative 103.4 kilojoules. But how are we going to find the desired equation here? So finally, we have to make sure that this appears at the bottom. So first thing is we have to look at the ones that are the same on opposite sides. So here, for example, is 2NO in the reactant, and I have a 2NO on the product side, so that would cancel. So anything, they're the same, but they are found in the opposite side, you have to cancel it. And then the rest, if they're not the same, you can just simply bring it down. So here we have 2NOCl